G'day team and welcome back to another video, and today we're going to start looking at sign diagrams. Now sign diagrams give us a really nice quick snapshot of the key characteristics of a graph, and we sort of just look at it as whether the graph is above the x-axis or below the x-axis. So you see here we've got some weird looking things here. Now these are my sign diagrams. Now you can see this straight line here has a little x, and I've got a little straight line here with an x. Okay, so this horizontal line represents my x-axis. Now this a value is either where my function, so my graph, cuts the x-axis or touches. So in this case we have a cuts the x-axis. Now we can have one side of my function above the x-axis and then go through, and then on this side it's below, and on this side we could go the other way. Now this little example here, what one do you think represents this function here? Have a look at A and then look to the left of A and check if the function is above or below, and then check to the right. Hopefully you chose this one. So to the left of my A value, you can see my function is below my x-axis, so that means it has to be negative. On the right, it's above, so it's positive. Let's have a look at another example. So I said they could be touching as well. Now you can see here it touches the x-axis, okay? So we've still got my A value and we're just touching. Now, when we're touching, it either has to be positive and positive because it's all above, or it has to be negative and negative because it's all below. Now again, just like before, which one of these two sign diagrams do you think represents this function here? Hopefully you said this one here. If we look at this key point A, look to the left, my function's above the x-axis. If I look to the right, my function's also above the x-axis, so it has to be plus and plus. Okay, now my final example is when I have an asymptote. Okay, so we've done a little bit of talk with asymptotes. They are lines where our function never touches, but that's a really key point on a graph. So instead of a solid line for a touch or a cut, we put a dotted line for an asymptote, like our dotted lines on the graph. We treat asymptotes like an axis intercept. So to the left of A, to the left of my asymptote, it's below the x-axis, and to the right, it's above. So I've got minus and plus. Really important that we're using that notation of a dotted line for my asymptote there, okay? All right, let's have a bit of a practice. So I've got two graphs here, one fairly simple one quite tricky one. So let's start with the simple one. First thing I want you to do is always draw a straight line, arrows on either end, and an X. So they're going to give me my axis that we're representing and shows that it goes on forever each way as well. The next thing we have to do is identify any cutting X points, touching X points, or X asymptotes. So I've got a cut at -2 and a cut at 3. Make sure you're not choosing a maximum or a minimum, only where it cuts the x-axis. So I've got one at -2 and I've got one at 3. Now, on this side of -2, so the left side, my function's above the x-axis, so we put a plus. In between my -2 and my 3, you can see my function's below the x-axis, so we put a negative. And then to the right of 3, it's positive, so I put a plus. Nice and simple, isn't it? So now that we've done the really simple example, let's have a bit of a go at the trickier one. So nice straight line, arrows on each end, and an X. Let's find our key points. They can be cutting, touching, or an asymptote. So I've got a cutting point at -5, so that's a solid line. I've got a touching point at 2, so that's also a solid line. But then I have an asymptote at 4, so that has to be a dotted line. Okay, so that's at 4. Now, these don't have to be to scale, okay? Just showing the differences. Now, to the left of -5, it is below. In between negative 5 and 2, it's above. And then between 2 and our asymptote at 4, it's also above. And now can you see, thinking back to up here, when it touches, we've got plus or minus minus. See how I've got plus and it touches it too? And then to the right of my asymptote, it is below. So we're done there. All right, not too tricky when we are given the graph. Can get a little bit trickier when we only have the equation. Now, if I have a term that's x minus a to the power of 1 equals 0, we get the x-intercept, and it's just this value, swap the sign around. If it's to the power of 2, we know it touches, and if I have x minus a over x minus b, the numerator, when it's equal to 0, is my x-intercept, but when my denominator is equal to 0, that's actually not true, so that's how we find our asymptotes. So it's really important we keep that in mind when we start working through. So we've got some examples here. So let's have a look at A to start with. So what we need to find our key points. So I've got x plus 2 and x minus 2. Now, when x plus 2 equals 0, x equals negative 2. Okay? And when x minus 2 equals 0, x equals 2. So they're my key points on my sign diagram, negative 2 and 2. It's really hard to see if it's going to be above or below given just an equation. But what you need to choose is a number that's less than, in between, or greater than. So to the left of negative 2, I'm going to choose negative 3. Between negative 2 and 2, I'm going to choose 0. And above 2, I'm going to choose 3. Because what we can do is substitute these x values into my equation. And if the result is positive, then it's above the x-axis and I can put a plus. If it's negative, I know it's below the x-axis, I put a negative. So if I put negative 3 into this equation here, I get negative 1 times by negative 5. 2 negatives make a positive. If I put 0, I get 2 times negative 2, which is negative. And if I get 3, I get a positive times a positive, which is a positive. Just as simple as that. Let's have a look at part B. Now, this one's a little bit tricky because it's got a 3 here. But if I write 3x plus 2 equals 0, 3x equals negative 2, x equals negative 2 on 3, that solves this one here. And then this one here, x equals 1. So I've got x equals negative 2/3 and x equals 1. So they're the values I put on my sign diagram. So negative 2/3 and 1. Now, this has a square attached to it, so I know this is going to be a touching point. So either side's going to be the same value of, or same sign. So a number less than negative 2/3 is negative 1. A number between the two is 0, and a number greater than 1 is 2. Now let's substitute those in. So if I put negative 1 in here, I get negative 1 squared, which is positive, and then negative 1 take 1 is negative, so I get a negative. If I put 0, I get a positive, I get a negative, that is also a negative. If I put 2, positive, positive, that means I get a positive. And we know these are going to be the same sign because it touches at this point. All right, and finally, C. I've got a fraction, so I know I'm going to get a 0 and an asymptote. So x plus 2 equals 0 gives me my x-intercept, so that's x equals negative 2. And 2x equals minus 3 equals 0. 2x equals 3. Divide by 2. 3 on 2. That's going to be my asymptote because it came from my denominator. So when I put these on a sign diagram, x equals negative 2 came from the top, so it's a solid line, but 3 on 2 was an asymptote, so we need the dotted line. Now let's go negative 3, 0, and 2. If I put those into my function, negative 3, I get a negative on the top, I get negative on the bottom, so I get a positive overall. If I put 0, positive on top, negative on the bottom, we get a negative overall. And if I put 2, I get a positive overall. Now, I am missing my little x's on all of these. Make sure you put that correct notation in. Hopefully that helps a little bit, gives you some good examples to work off of, and I'll see you in the next video.